Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. In this video we are covering CCNA Semester 2 Routing and Switching Essentials, and this is Chapter 6 Static Routing. This section is 6.3 Review of Classless Interdomain Routing and Variable Length Subnet Mask. Upon completion of this section, you should be able to explain the use of legacy classful addressing in a network implementation, explain the purpose of classless interdomain routing in replacing classful addressing, design and implement a hierarchical addressing scheme. Classful network addressing in 1981, RFC C90 and RFC 791 described an IPv4 classification system for different sizes of network. We had Class A for large networks, B medium-sized network, and C small address were defined with specific format for the higher order bits. Okay, so at that time they had different classes, Class A, B, or C. So you as a customer, when you wanted to buy an IPv4 address, the first question would be, okay, well, what class would you require? Do you want Class A, B, or C? Now, depending on what class you ask for, that many addresses we can get. So with classful IP addressing, the subnet mask of a network address could be determined by the first 3 bits of the address. So do you remember these classful addresses? We had Class A, anything starts with 000 up to 127.255.255.255. Class B starts with 128.0.0.0 up to 191.255.255.255. Class C 192.0.0.0 up to 223.255.255.255. And then we have a class multicast address, Class D, which is 224.0.0.0 all the way up to 239.255.255.255, and then the rest are experimental addresses. So Class A address, always on the binary, the first octet. Remember, these are rest are all zeros, but this bit, the first bit, is always 0. So from 0, and if you change the rest into ones, that's going to equal to 127. So from 0 up to 127. The first octet is a network, so this represents the network. The rest that represent the hosts. Class B, for example, the first 2 bits are always going to be 10. So 10, if you have all zeros in the end, that's 128. If it's 10 and then all the rest are ones, then that's going to equal to 191. So the first 2 octets, they do represent the network. This is a network, and last 2 octets, they represent hosts. And Class C, the first 3 bits are always 110. So if you set to all zeros at the back, that's going to be 192, 110, and then all ones, that's going to be 223 at the end. So the first 3 octets are the network, and last octet is host. So classful routing protocols, such as RIP version 1, only need to propagate the network address to known routes. Updates do not need to include the subnet mask. The receiving router examines the value of the first octet in the network address. Routing protocols since RIP version 1 and IGRP are classless. So now we have a classless routing protocol. These ones, they do send a subnet mask in the routing updates. Classless routing protocol you're going to be learning on this course are RIP version 2, OSPF, EIGRP, and ISIS, which we're not going to cover on CCNA routing and switching. BGP, you're going to cover external BGP on CCNA routing and switching, but then we have internal BGP as well. Not in depth. More in depth in BGP is CCNP routing and switching. So classful routing protocol example. Now router 2 will send an update to router 3, but it will summarize all the networks 172.16.10, 172.16.20, or 172.16.30 up and send it to router 3 as just one network, 172.16.00. Okay, the question now here is, if I mark it, this is our network of router 1, 172.16.10, and now that's subnetted, it's a class B. By default it should just be 172.16, that's it. And router 1, it will advertise this. Will it advertise as just 172.16.00 or 172.16.10? If we advertise only as 172.16.00, when it sends it to router 2 is going to have that on his network 172.16.00, so it's not going to accept it. But because the router 1 has a subnet mask 24, it's going to advertise that 172.16.10, and router 2 is going to look at it and say, okay, well, we do have a subnet mask 24, so we must have been summarizing, so it's going to keep it as 172.16.10. But as they advertise it to a different network, different major network, like 192 here is a different major network, now it's going to summarize it to 172.16.00. So if they advertise it within the same network that has been subnetted, they will understand, they will know the subnet has been, or the network has been subnetted. When router 3 receives the update, he applies the classful mask for classful B network. Router 3 adds 192.168.0.16 to its routing table. Okay, I'm going to show you something about classful routing very quickly here. I'll open the paint. Okay, very quickly here because I don't want to spend too much time, but imagine that we have like this, we have 3 routers, yeah, and these are connected like this. Router 1, this is our router 1, this is our router 2, and this is our router 3. Now router 1 has got an connection. Let me put the connection this side, has summarized it to say 172.16.1.0/24, and router 3 has got similar connection, and this side has summarized that to 172.16, say 100.0/24. Now here between them, just think another major network here, 192.168.1.0/30 maybe, and this network is another major 10.1.1.0/30. Okay, now when router 3 sends an update towards the router 2, it will summarize this, it will send an update towards router 2 as just like 172, so if I write it here, it will send it as a summary address 172.16.0.0, because it doesn't send the subnet mask. Okay, so this comes in router 2 like this, from here to here, and the same thing is going to come from router 1 because it's going to summarize this and come to here. So now as far as router 2 is concerned, it's got 2 updates from 2 different neighbors for the same network. So now it's going to start sending, when the packet comes in, say a packet arrives at router 2 for destination say 172.16.100.1. Router 2, what it's going to do is going to load balance. It's going to send 50% of the packets this way and 50% of the packets this way. Now as you can see, 50% of the packets, 50% of the packets, they're going to make it. Another 50% of the packets, they're not going to make it. Because this is a problem if you have a discontiguous network in the classful routing. So, classful address waste. So class A has 50% of the whole addresses available on our IPv4 from 32-bit. Class B has 25%, Class C has 12.5, and D, the rest 12.5. That's D and E. So Class A networks from 1 to 126. So we have 126 network, and each network has 16.7 million addresses. That's quite a lot. And there's companies who actually have Class A address space. So they have, for example, one Class A address, and they have all these 16.7 million addresses, public addresses available, where the rest of the world, they're fighting for scrap, where you have companies who have 16 million of them available. Class B networks, again, from 128 to 191 networks, and possible networks that we can have here are 16,384. Each network will have 65,534 hosts. So each network, each out of these 16,000 networks will have 65,534 addresses. Here we are talking about public addresses, yeah? Class C address, we'll mixture public and private. Class C, from 192 to 223, possible networks that we can have is 2,097,152 networks. And each network will have only 254 hosts. Now, they realized very, very quickly that this is not viable or not scalable at all, because we're running out of IPv4 addresses. So that's why you get rid of it, classful addressing, and then 1993, very quickly, they find out, okay, well, we have to make the obsolete classful addresses, and we have to implement classless interdomain routing. So classless interdomain routing network addresses include a subnet mask, also known as network prefix or prefix length, such as /8/19. So now when you want to purchase an IPv4 address, they don't ask you what class would you like, A, B, or C. Now you say, okay, how many addresses would you need? 3, 4, 10, 100, 1000, whatever. Not 17 million at one go. So classless interdomain routing, when we send an update, now it needs to send an update. We can send it as a summary route or whatever we want, but subnet mask is going to be within an update. So when we subnet in IPv4 addresses, so we take an IPv4 address, a network address, and we can subnet it. So we can subnet only the host portion. The network portion, the ones on the subnet mask, we can't touch. They're not ours. Only thing we can touch is the host portion, the zeros. So for example, if we borrow 3 of these zeros, so what we're doing here, we are taking these 3 zeros and we're changing them into ones, right? So if we change 3 zeros into 1, that's the formula 2 to the power of 3. 2 times 2 is 4, times 2 is 8. We create 8 subnets. But every time you borrow the bits, you're gonna reduce the number of hosts. So instead of 254 hosts that we had before, now we have only 30 hosts each network. Well, we created 8 subnets, but each subnet only has 30 hosts. Variable length subnet masking. One subnet was further divided into create 8 smaller subnets. So what you can do is you can subnet the subnet. So if we create one subnet, we can continue and create another subnet from that subnet. So variable length subnet mask allows the user to use a different mask for each subnet. After network address is subnetted, those subnets can be further subnetted. So VLSM is simply subnetting a subnet. VLSM can be thought as a subnetting. Individual host addresses are assigned from the addresses of subnets. So for example, say the network 10, yeah, here, this network 10, we have subnetted that. That's our default, that's our class A address 10.0.0.0. Then we have created the different subnets here. We created 256 subnets. From this, we have subnetted. Now if we take one subnet, imagine that we take that subnet and we subnet it even further, that's subnetting the subnet, right? So we can do that. Now we can create, from that subnet, we can create another 256 subnets. So classless interdomain routing and route summarization. Classless interdomain routing also reduces the size of routing table and manages the IPv4 addressing space. More efficiently, we are using route summarization. This is called also known as a prefix aggregation. Routes are summarized into single route to help reduce the size of the routing table, such as when summary static route replaces several specific static route statements. Summary routes can be configured by both static routes and classless routing protocols. Or supernetting. Supernetting summarizes multiple network addresses within a mask that is smaller than the classful mask. A supernet is always a route summary, but a route summary is not always a supernet. Okay, so let me just try. I'll open a notepad and I'll show you this a little bit in depth. So if I open a notepad, where is it here? Route summarization. For example, if we have say 172.16.1 .00/24, we have summarized it, and we have summarized it few networks. Yeah, let's take 4, right? It will be easier to explain. So 1.0, 2.0, say 2.0, and then the last one 3.0. These networks have been subnetted. So instead of me creating a static route for all of them, say IP route 172.16.0.0.255.255.255.0 S00, right? I can summarize all these. Yeah, I can summarize it into one network. Yeah, so okay. So the summary address for these networks, for example, it would be something like 172.16.0.0/22, right? That's our summary route. Okay, to do it? right? I don't want to like just go that fast. Have a look at this. How can we summarize it? For example, 172, we don't have to convert it in binary to get our summary address. We don't have to convert the 16 either, because all of them, they start with 172.16. The next, I'm going to do it everything in the binary. So 0, 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8. That's our 172.16.00. So if I do the next one, let me just go here, like this. 1.0, we change this bit to 1. 2.0, we change this bit to 1, sorry. And 3.0, we change those 2 bits, 2 zeros into 1. So that's 172.16.00. Okay, so if I can put it as equals there. Now to get the summary address, what I'll do, or you should do, is put them back to what it was. So 172, to find out where the difference is. So if you look like from the left towards the right, how many zeros are the same? So up to here, they're all the same, right? So we don't really, after when they start differentiating, we replace it, we just say it's 0. And we start counting. That's 8, and 8, that's 16. 16 bits are the same. 17, 18, 19, 20, 21, 22. So 22 bits are the same, right? So I put here 22 bits are the same. And then we convert this back to the decimal. So 172.16, we didn't touch that. And then we put convert this back to the decimal, it's going to be 0. And after whatever has changed, it ends up being 0. So 172.16.00 / 22, this is your summarization, root summarization. Now, what is supernetting? Well, supernetting, when you think of it as, okay, the classful addresses, say for example, 172.16.00, yeah? Oh, sorry, 00. This is classful address. 172.16.00 / 16 is our classful address. Say that we have another classful address like this. Say we have a 17.0, 18.0, and 19.0, right? These are the classful addresses. If we summarize a classful address into smaller bits or smaller summary than the classful address, that is called a supernetting, when we are bundling classful addresses into one summary address. Okay, so should we do that? Should we do this as well? Okay, let's do it. Okay, I haven't done this beforehand, so okay, 172.16. So here is our difference. Yeah, so we're gonna start converting this. So 16 is 0 in 1 to 8, 0 and 64, 0 and 32, 1 and 16, and then the rest is 0, 1, 2, 3, 4, and the rest 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 172.16, 0, 0, 2, 3, 4, 5, 6, 7, 8. Let me just move this. Okay, so here a 16. The 17 is going to be the bit here. So 16 and 1. 18 is going to be 16 plus 2. 19 is 16 plus 3. So now to find the summary address, we need to count how many bits are the same. So 172, that's 8 bits. 9, 10, 11, 12, 13, 14. 14 bits are the same. So say 14 up to here. So 14 bits are the same in all of the 4 addresses. Now all we need to do is convert this back into decimal, which is going to be 172 dot. If you convert, even though these are zeros now, all of them, this bit we have to convert it back to decimal, which is 172.16.00 / 14. 14 bits are the same. That's called a supernetting now, because we're going from the class full address into smaller. Cool. Let's move on. Classless interdomain routing and root summarization. Yeah, this is what we have. 192.168 to 23. We summarize all these addresses into smaller / 20, for example. That's called the classless interdomain routing. Static routing. So instead of saying like IP root each one, then we can just say once IP root. Same as if I go back here. If I say, I can do it like this, IP root 172.16.00 with a mask 255.255.0.0, and say the exit interface is S00. Like this, you can do for all 4, 17, 17, you can do 18, you can do 19, or instead we can do a summary address. So for example, we can do 172.16.0.0, but we can say 255.252.0.0. So this, instead of summarizing into, instead of advertising or creating a 4 static routes, instead of creating 4 static routes, we create only 1 static route. So we reduce the table, our routing table. Okay. Thank you for watching the section 6.3 reviewing of classless interdomain routing and variable length subnet masks. Please have a look at other videos and don't forget to subscribe. This has been Astrid Krasniqi. Next video 6.4, configure, summary and floating static routes. Bye bye.